My work today that I'm presenting is about the electroencephalographic response to intermittent photic stimulation in a cohort of patients with idiopathic generalized epilepsy. Essentially, idiopathic generalized epilepsy is a condition that affects millions of people worldwide, and a significant portion of patients with idiopathic generalized epilepsy have this condition called photosensitivity, which means flickering lights at certain frequency ranges can trigger seizures in them. So if you've been to the movies and you see disclaimers before the movies or during light shows, it's for this, right? So our question with this study was, well, can we quantify this? Why are only some people with idiopathic generalized epilepsy photosensitive? And why are they photosensitive to only select frequency ranges? So in order to answer that, we had to look at electroencephalography data, EEG data, and then borrow ideas from dynamical systems and apply it and see if we can quantify this, say how photosensitive someone is. So typically, patients with idiopathic generalized epilepsy or people with generalized epilepsy get brought into epilepsy monitoring units where we perform this procedure called intermittent photic stimulation with the hope of triggering seizures in them in order to better understand their condition so that we can instruct them better on how they can avoid certain types of situations which may provoke seizures in them. For the clinical purposes, we are only interested in whether someone is photosensitive or not. We're not interested in quantifying them. So the question that we wanted to answer was about, well, how quantifiable is this phenomena per se, right? So we obtained appropriate data, which is EEG data from patients with photosensitive idiopathic generalized epilepsy and patients without photosensitive epilepsy, but still idiopathic generalized epilepsy, and also patients with focal epilepsy, which is sort of a control group for the other two. Yeah, so we got the EEG data from them, and we wanted to answer this very simple question, right? When we are stimulating at a particular frequency, say at 12 hertz, what is the occipital cortex or what is the posterior cortex seeing? Is it also seeing 12 hertz or is it seeing something else? Is it seeing 24 hertz or is it seeing 6 hertz? And this has implications for the stability of the system. There is considerable evidence for the occipital cortex as a non-linearly coupled system, and non-linearly coupled systems have certain behaviors. And having certain frequencies such as sub-harmonics to be represented in those non-linearly coupled systems has connotations with the stability of those systems. So if we can extract the frequency response spectra for a particular stimulation frequency from these patients, we'd be able to do this in a much more objective fashion. And that is what we found. We found that patients with idiopathic generalized epilepsy who are photosensitive typically responded in the sub-harmonic range, which means if you stimulate them at 14 hertz or 15 hertz or 16 hertz, they, instead of responding at 14, 15, and 16, which is typically expected, they responded with halves and one-thirds of those frequencies. But also they had this preference for snapping back to alpha rhythm. The alpha rhythm is sort of a preferred rhythm for occipital cortex. It's highly stable across individuals, and so it seems as though the patients who are photosensitive, they are not able to entrain their cortex to the external cue, and the brain instead does whatever. And this is again mathematically quantifiable, and it's a continuous process, and we're really excited that we got this result with a very small cohort.